Hello everybody, welcome to another Thought Fuel episode. I appreciate you joining me this week. Today we're going to be talking about RxJava streams, and particularly a nasty bug which can show up if you're not looking for it. It can be a rather subtle issue if you don't know how to spot it, so we're going to go into the details of what it is, what it looks like, and how to fix it today on Thought Fuel. Let's get right into it. When it comes to understanding how a nasty bug really works, there's no better way to understand it than by looking at a piece of sample code. So we're going to dive into two particular examples. The first one is going to show you the bug, and the second one is going to fix it. Since RxJava excels at asynchronous operations, we're going to have three networking calls in this example. The first networking call is going to make an asynchronous call to a server so that it can get some sort of access token. After that, the subsequent two calls are going to use that access token, zip the results together, and send them down to the final result, where we can display them to the user. Even though what I just described could vaguely sound like an OAuth2 token exchange of some sort, I don't want you to focus on too much about the authorization aspect of it. Instead, focus on the RxJava aspect of it, and how we're passing data through our flow. As you can see in this example, the very first networking call is to get an access token. That access token is then saved inside of a local variable so that the subsequent two networking calls can be authorized for their cases. The second networking call then utilizes that access token, gets its own result, saves it into another local variable, and finally, the third call does the same thing. This time, the result of that is passed into the subscribe, and the two results that we need are accessed via their local variables. Now, if I were to run this example, it would most likely work without a problem. But we actually do have a problem here, and that is we're not keeping our streams clean. And what do I mean by clean streams? So instead of referring to information that's only provided within the RxJava call chain, we're actually saving some information outside of that scope into local variables that are outside of the scope of the entire call chain. In this simple example, we're probably not going to run into too many issues, and that's because it's so simple. The only thing we're doing is reading and setting these variables inside of the call chain. Now imagine, instead of those variables living inside of the function, let's say that they were class-scoped variables, and we had other functions that were running that would read and write to these variables. By the time we finish the RxJava call chain, we may have a very different result than what we're looking for, because we have multiple scopes and multiple threads reading the exact same pieces of information. If that situation sounds like a nightmare waiting to happen, you're totally right. It definitely sounds like a nightmare waiting to happen. So what can we do to fix this? Well, in order to do that, we need to think about scopes. Whenever we're learning programming for the first time, we tend to think about variable scope in three different ways. We have local scope whenever a variable is available inside of, say, the body of an if statement. Then we have method scope, which is available in a broader sense to everything inside of a particular method. And of course, class scope, where everything is available inside of the entire class. Now, that doesn't always work with the case of RxJava. We need to think about a couple more scopes where we keep everything inside of the RxJava chain, as well as available to each of the respective threads. We've solved a lot of these issues at hand by using a very familiar technique. So just like how we inject all of the necessary dependencies into the constructor of a class whenever we do unit testing, we followed a very similar pattern here. In the first example, I started off by creating a networking request to start off my entire RxJava call chain. Here, I've changed that approach. Now I'm using a single to start off the entire process. In this case, this is like a constructor injection. So I just provided a model which I'm going to be using throughout the entire rest of my call chain. If you take a look at what's inside of that model, you can see I have an access token, as well as a piece of information to be able to store the results of my first network call, as well as the second network call. By the time I get to my first flat map, that's whenever I'm doing my first asynchronous operation. As you can see what I do inside of there, I kick off my access token request, and I do a flat map one level deep inside of my call chain. So effectively what happens is, after the access token call finishes, the inner flat map is called. At this point, I have access to the model which was given to me at the very beginning of the call chain, and I have access to the access token. So all I need to do is simply add the access token to the model and return the entire thing. Moving down to the second flat map, that's whenever we encounter our second networking call. And now I have access to the entire model, which only contains the access token for now. In this case, you can see I'm following the exact same set of steps as I was in the first flat map. This inner flat map allows me to wait for the second asynchronous operation to complete while having access both to that result as well as the access token that was provided on the global model. So in this case, all I'm doing is putting that second piece of information onto the global model and passing it down. I have access to all of the information that I've ever derived in the third step. It's just a rinse and repeat of the previous two steps. And now you can see why this is working, because all of the information that I'm gathering is being slowly accumulated inside of this great model that is finally going to be passed into the final result. And I was able to do this by keeping all of this information inside of my RxJava chain and allowing it to pass between the threads as necessary without messing anything up. I'd like to make one last point here. You'll notice that I use the exact same model for all of the different steps inside of this RxJava call chain. So by the time the final step rolled by and we have our subscribe, I had access to everything including the access token. Now, more than likely, I probably wouldn't need access to the access token because all I cared for were the results for the previous two networking calls. The choice is really up to you and your use case. If you want to pass all that information through, you can use one model and pass it straight down onto the subscribe. In some ways, that'll make the maintenance burden of keeping this RxJava chain as relevant as possible pretty light. In other cases, you may prefer to have different models for different steps, or at your very last step, you may prefer to strip out any information that you think your subscribe may not care about. Thank you for joining me today on ThoughtFuel. I hope you found it helpful and maybe even a bit thought-provoking. I have new content exclusively for Android developers every Monday at noon. If you haven't subscribed yet, I certainly invite you to subscribe now. Otherwise, I'll see you next time. Thank you, and happy coding.